Yo, hello. And in last stream, we managed to implement Half-Life movement in my Minecraft clone. This is my Minecraft clone. We had big success. And today we will try to implement ambient occlusion. Now, what is ambient occlusion? It's basically this image from the thumbnail where the ambient occlusion is these little like dark spots on the edges. That's ambient occlusion, and my motivation for all of this is every video I post documenting my progress of the clone, everybody like was annoyed there's no ambient occlusion. And the one feedback that hurt the most was the Cherno when he reviewed one of my C++ Minecraft clones. None of my Minecraft clones have ambient occlusion, and he said this.
Also created this massive crater, which, as I mentioned earlier, really needs some ambient occlusion because it's really hard to see what's going on. That would improve the look of this dramatically. Yeah, and we've just...
And you heard it here first, folks. He says it himself. Ambient occlusion will improve the look of this dramatically. Well, that's the motivation. We'll try to implement it. By trying, I mean we'll try for 1 or 2 hours, and hopefully we can do it. I have opened few resources I found on the internet, and this one seems to be the most promising, since here is just a simple function that goes to each vertex. Like when I create the mesh, I just have to go over each little vertex. The cube has 8 vertices. It's just all of these corners. And here we look at this corner. And for this corner, we have to look at its sides, 2 sides, and one behind it. That's it. And he has found that there are 3 cases. And he makes this simple function that just takes in for each vertex as a boolean. Does it have one of its sides? Does it have the other side? And does it have the corner behind it? And depending on these values, it will output a number, which is from 0 to 3. And depending on that number, probably in the shaders, we'll have to change a little bit the coloring, and which would improve the edges, because right now all of my edges in all of my Minecraft clones, look at how the edges like are the same everywhere, and it just makes it hard to see the depth of the terrain, to see the to differentiate each block. And we can even look in Minecraft, the original Minecraft, how it looks for them. So prepare your cup of coffee. I've prepared mine, and hopefully we'll have some progress this stream. Now I'm opening Minecraft to see how they implement it. And in Minecraft, I know in the settings you can even turn it off. So we will even turn it off to see the difference. So now I think it should be on, but let's see in the options, video settings, and I think it's called smooth lighting. Off, light shadows, dark shadows. Yeah, smooth lighting. Yeah, now it's exactly like my game. Yeah, now it's 1-to-1 like in my game. Look at how the edges, there's no differences. And now smooth lighting on, and now the edges are easier to differentiate. And here, especially with the lamp. So that's what we're going to do. Now the issue is, my main concern is that my Minecraft clone doesn't have just these simple blocks. Like if it was just these simple blocks, it would be an easy problem to solve. But we have like a repeater. What are we going to do with the repeater? We have pressure plates. We have, oh, the lamp is easy. We have the torch. How will the torch work? Like there, I have the complex shapes, and I'm not sure how to they are the main concern for me. redstone torch. Let's see how in Minecraft they do it. Okay, do they do anything? I think not. Okay, for this, they don't seem to have ambient occlusion, but if you look at the piston has it for sure. Because it's a simple block, but let's extend it. And even extended, look at how, like I've noticed it when I made one of my thumbnails. When I compared my piston to their piston, it's easier to see there. Like here, look at how, I'll just open the original thumbnail so it's easier to see. This is important to bring awareness to these more complicated shapes. Yeah, here. Notice how my piston, look at how it looks. No ambient occlusion. Like the blocks, they will be simple to solve. Sure. But look at their piston. Look at how even here there seems to be ambient occlusion. And is it here as well? The more complicated bases. But we don't need to like, it's completely fine if we solve ambient occlusion just for blocks. That would be huge improvement. Even if we just have ambient occlusion for these grass blocks, that I will be fine with that. I'll be completely fine with that. So that's what we can focus on. And today I've continued to play around with the bunny hopping and the hand bob effect. I just looked at this the whole day. It's so cool, man. The last stream we made such a big improvement, and it was for an hour and a half of work. All because of the cool tutorial we found. Okay, so let's concentrate and focus on implementing the ambient occlusion. Now, we should go towards the code. Now, I need to go where we create the mesh, where we generate the mesh. It should be in the subchunk class. And here, I just collect data of the neighbors. I collect data. And here, for the whole subchunk, I'm creating a mesh. Which I fill up with positions, UVs, colors, and indices. And before I give it to the mesh, I store it in these lists. Like the positions is an array list of vector 3fs. Float vectors, so I go over every block, and for every block I ask it to give me its positions, its textures. Here, yeah, from the block itself I have this method get positions. So for example, where is the block? Yeah, here, this block, or like something else. The iron block. Yeah, let's do the iron block. Iron block. Yeah, I just create a cube. I create a cube. And when I want to get the positions, I just return the positions, which is all generated from this cube mesh. Yeah, I've abstracted a lot of it, so it will be quite difficult to make changes Yeah, this is the other problem. This is more than 300 hours of work. I've abstracted a lot of things, and going back and trying to make some changes will be hard, because every programmer knows refactoring is a huge pain, especially if it's down to the absolute base of the code. So we can try, okay, we can focus just on the iron block maybe, and to try to make it aware of its neighbors. Let me think about it. Yeah, we generate it. Yeah, here we generate it. Yeah, we conditionally add the faces of all of the sides, depending if it should be called or not. And actually, this culling, it's an integer that has packed data of all of its neighbors. So maybe we can use it for the ambient occlusion as well, because in this tutorial, for this corner, we need this neighbor, but we need the corner as well. And we don't have information for the corner. That's another issue we found. So we found 3 issues. So one issue is, what do we do with these more complicated shapes like the piston? This is the first issue. The second issue is, how are we going to refactor the code, since I've abstracted most of it, and it will be difficult to make changes to the existing big project. If we were starting over like the Godot project, I have a different Minecraft clone that I've started in Godot. There it will be easier. And the third problem is I know I have information if this neighbor is there and if this neighbor is there, but I don't have information for the corner. And this is a problem because if we get information about the corner, we'll need to make extra changes. And it would be perfect if we could make as little changes as possible, because it would be extremely easy if I could just use this integer that has all the information of all the neighbors. It has the informations of... Actually, no. Actually, that the information I have is not for this and this neighbor. It's for the one below it, because this vertex, we can actually just screenshot this and go to Excalidraw. And here, yeah, so we're focusing on this corner here. And what I said is that we already have the neighbors. I said we have this and this neighbor, but that's not true. This corner is for this block, so we have the neighbors below it. So we have, because when you create, like when I create, for example, this block, I'm rendering this side, and this side, but this side here, this side, I'm not rendering it, since we cannot see it, and this saves up performance and compute. The same is true for the side below it. So this side is also not rendering. This is called culling. We are culling the faces. And I have information for, and to be able to do this, to know if I should render this side, I managed to do that by storing information of, like, if there is a block here, if there is a block here, here, and here below it. I have that information. So for ambient occlusion, let's say we're targeting this vertex. We have to go, for ambient occlusion, we need to store data for this vertex, this vertex, this vertex, this vertex, and the four below it. And so let's say we're targeting this vertex. For this vertex, we need this block, and this block. We need information for these blocks if there's something there or not. So we can make it darker like that. Here, notice how it's darker. And I assumed I have information for at least this block and this block. But that's not true. I have information for this block and this block. So it turned out I don't have information for this block, and this block. So for all three of them, I have no information. So for sure, we will have to make changes. That is a certain. Now, where are we going to handle all of this? Because if you go back inside of the code, for example, we focus just on the iron block since it's just one cube. All of this code is to prepare the data for one simple cube. And I have abstracted it this way so that we can make more complicated shapes, because every block in Minecraft is made out of cubes. Even the grass is made out of cubes. Here is made out of 2 cubes, where this is just for the foliage, the grass, where actually it has only 2 of its sides visible, and this cube has 2 of its sides visible. But that's another topic. So for the iron block, how are we going to do this? Because the information I give it is this call size integer. This integer has with ones and zeros, I've packed data. Packing data means that I'm storing here a lot of information. And the information is, like we said, the neighbors. But when creating this block, I'll need a lot of neighbors, because I'll need these 3 neighbors just for this vertex. And for this vertex, I'll need this neighbor, and this neighbor. For this vertex, I'll need this neighbor, and this neighbor. And for this vertex, I'll need this neighbor, and this neighbor. So for all of these 4 vertices, I'll need all of these blocks. I have to know if they're here. And for below, I will need all of these blocks. I will need all of these blocks for these vertices. And this is just one block. And I need this block, this block, this block, and this block, so I know if I should cull the sides. Because if the block is hidden away, we don't even need to handle ambient occlusion. Like, it's not going to be rendered. This is to save performance. So look at how much we have to work with just for one block. I'm clearing all of these blocks, so it's easier to see what we need to target just for one block. Yeah. Time set day. We need all of this just for one block. And this is an issue because there are many blocks. And if it turns out the whole block is hidden away, we don't even need to gather all of this information. And How are we going to approach it? Because now if we go back inside the code, here most of the stream will be just thinking and brainstorming. Like programmers most of the time are not writing code, they're just thinking. Because if we like rush and write bad code, the next stream when we try to add something else, it will become a mess and the project will end. And we're trying to make this long term. So let's go to where was subchunk, where we create a mesh here. So here for every block, what's this? Yeah, this is something else. So here I have a for loop for each subchunk. I can even prepare the Unity Minecraft clone where there it's easier to visualize some things. I'll prepare it. Unity Minecraft clone. While it's loading, so for each subchunk I go over every block, and if it's air, we continue because we don't have to do anything if it's air. Here we're trying to generate mesh, and there's no mesh for air blocks. And we continue on. And the next thing I do is this integer call sites. In it, I store information for the top, bottom, south, north, west, east neighbors, if they are there or not. Yeah, let's start this Unity Minecraft clone so it's easy to visualize. It's very easy to visualize in Unity what we're talking about. Now the Unity Minecraft clone is generating the terrain, which takes a bit of time. So I go over all the neighbors. So, and I store the information of the neighbors in this simple integer. And then I pass that integer when, like I have this block. Where do I create the block? Here. I have the block, which is like a class that I get from block factory, depending on the type. The type is a simple enum. The block factory is a class. I just give it the type of the block. The block factory creates the actual class we'll be working with. And that class has methods that will here generate the positions that are needed to generate the mesh. And this is where we need to focus our attention when we generate the mesh for the block, this line. And in this line, we give it information for the neighbors. And here we need to give it information for the other neighbors, since we give it information for this block, this block, this block, and the bottom one. And this block here. But as we saw, we need all of these blocks as well, and all of these blocks as well. And we need to figure out how to give that information. Here is the Unity Minecraft clone, and I opened it so we can easily see this is one subchunk. This is what I was talking about. And here you can see it has a mesh. This is the mesh. This is what we are generating. These cubes. This is what we are generating. And this is one subchunk. It's 16 by 16 by 16. And here, we are in the class called subchunk. And this class, in this function, is generating this mesh. Currently, we are generating. And let's say like we are currently working with this block. And this block looks at all of its neighbors. And here this face is rendering because there is no neighbor here. And we can see, where's the subchunk? We've highlighted it. Let's just highlight another subchunk. This one. We can look at how very few faces are rendering. Here, this is a block. And here, there's no face rendering. Because it has a neighbor. Because it has a neighbor. And another problem, now this is the fourth problem we found, is look at how this is another subchunk. Like this block, when it's looking for neighbors, it has to check if the neighbor is from another subchunk. Because here, like it looks for this neighbor in the subchunk, because the subchunk stores the information for all the blocks. And it has to first check if the block is from another subchunk, it has to communicate with that other subchunk. And that's extra code, and it's difficult to do. But since for culling faces, it was just a few blocks, it wasn't a problem. But now it's a lot more blocks. And we may need to abstract some code. Let's go back. Because here, look at, here we're going for the neighbors. Neighbor block. Here, how do we get the neighbors? Get neighbor data. Yeah, I've abstracted it away in a simple function. So beforehand, I get all the neighboring subchunks, all the neighboring subchunks. So when I am looking for neighbors for this subchunk, I beforehand get references to all of these other subchunks, and below and above as well. And X, Y, Z, and the normal. Yeah, using the normal, the normal is telling me that we are looking for the top neighbor. And here inside this function that we've abstracted, we know that we want the top neighbor. So here it's checking if the block above us is in the subchunk above us. If so, we have to communicate with that subchunk. Else, we just get it from the subchunk we are currently in. But this is an issue since this function only checks for these neighbors, not for all of these. And I'm not sure how are we going to tackle all of these neighbors. So we managed to think through the problem, and we found like around 4 or 5 issues that have come up. And so now we have to decide what is our next step. We have to decide what's the next step. So if we go inside the code, here we look at the top neighbor, bottom, south. We can leave this as it is, no problem. And what's this? Okay, that's something else. So let me think about it. Here we give it cull sites, and cull sites is an integer that stores information for all the neighbors, if they're there or not. And we can do a simple check. We can do a simple check here, like if if all neighbors present, stop. Just like with air blocks. Just like here, if it's an air block, to continue. And same way here, if the block is like hidden away, like this is our block we're targeting, and if this block is like hidden away, to just ignore it. Else, even just one side can be visible. Okay, just one side is visible, or all sides are visible, doesn't matter. We have to continue. And let's say just one side is visible. We're simplifying it as much as we can. Just this side is visible. What do we do? Currently, what we do is we give it information of the neighbors. And so it knows like all of these sites are taken. So we will not do anything with them. And this site is visible, we have to render it. That's the only thing we're doing. And the change we will do is now we have to calculate the ambient occlusion for this vertex, this vertex, this vertex, and this vertex. And to do that, so for this vertex, what's the information we need? It needs this site, and this site. Oh, so we even need to look at even more blocks, like it's completely hidden away. All of this, all of it. We need all of the blocks around it, all of them. Because if this site is visible, and the ambient occlusion for this vertex needs this block, and this block. And how are we going to get information for them? The only thing we will focus on, we'll simplify it. The only thing I care about is this block type air or not? That's the only thing I care right now. Is it air or not? This block and this block. And where is this code generating? Let's see. If we go here, so here we check if the block is hidden away. And as it turns out, no, this site is visible. So we need to continue on. We continue with the code. And here we tell it, these are your neighbors. This is your data for the block. Get me the positions of each vertex. That's it. Get me the positions for each vertex. And then give me all the for each vertex the information for the textures, then information for the lights, and then information for the colors. And I just store them away in array lists. And I continue like that for every block, continuing to store in these array lists. And when I'm done, for the entire mesh, I give all of the blocks vertices, all of the blocks textures. So where should we make the change? So here, where we give it the vertices, probably here. So let's go back to our iron block. Iron block here. Now, for the iron block, we focus on it since it's very simple block. It's just a cube. So here, here we get the information for the neighbors for culling. Now we give this information when we generate the block. Here we just set it up to prepare it with information. We tell it the shape of the block. It's a simple cube. We tell it, I I think this is for the texture from the atlas. Where is the atlas? Where is the atlas? Atlas PNG I need. I need this one. Yeah, here I just give it information that it needs to use this texture. Here, it needs to use that texture. And here, I give it information on how to lay out the texture. But here it's very simple. Like I'm telling it to use the for each side to use the whole texture, because for some here, for example, the piston, some faces need just this part of it. But here the case is very simple. Next, I set up the lighting according to the neighbors, and I set this is for shadows. Then I set up colors, and I hit generate. So, and it will generate this face. It will generate this face because when we go inside of generate, here, it has this integer call faces, because here we conditionally create each of the faces. So, which face is this? It's, where are we looking here? We are looking towards positive Z south. We're looking, this is the south face. This is the south. So here it will go towards here, the south. And it will see that for the south, here it's empty. So we should render it. And all of the other faces, the code will see that it's not empty. So they shouldn't be rendered. And so we're rendering it. And this is probably where we need to add changes for ambient occlusion. So conditionally add face. It's a simple function. We like create the 4 vertices. Yeah, it's for loop that runs 4 times. And for each of the 4 times it runs, I use this unit cube. And I just make changes to its vertices so that it has proper coordinates. This is just to generate for each of these 4 corners, the positions. And we need, the biggest problem is we have to figure out where to position the code. Where should we position the code? Let me think about it. I assume my first idea is to be right here for each of the faces. Like to have a function, like to have a function here for like handle ambient occlusion for south face. And that's it. And here, just like for each faces, I handle like the creation of the positions of the vertices. Here, for each face, to handle the ambient occlusion. Sure, there's no problem with that. And what would that function do? We are focusing just on this face. What this function will do, it will go through all of the vertices. And it will look for neighbors. Like this is, the function will be very simple. We are using this guide. The function is very simple. It's looking for these 3 neighbors, and depending if they're type R or not, it will output a simple number. That's it. It's very simple. The hard part is we don't have the neighbors. We don't have the neighbors. since we're here in the code. So what do I mean? We're here and we're starting with this vertex. We have to go over all of these 4 vertices. But let's say we're here. And for this vertex, we need this block, and this block. And we are here in the code. And here in the code, the only thing we have information about is this integer curl faces. And the only helpful information it has is if this is taken or not. But since we're rendering this face, like this place is free, so the information is useless. So what we need to do is here to give extra information on like the neighbors, the other neighbors information. And this other neighbors information, we'll use it in our new like ambient occlusion for face function, and we'll give it the information of the other neighbors, and it will do its thing. So how do we get this information, and what should it store? That's the main question, because what should it store? Because I'm asking that because here we're just looking one face, and just this face, for all of its corners, we will need all of these blocks that we don't have information for. But the worst case scenario, oh, it's an Enderman here. The worst case scenario is if all of these are, let's go peaceful mode. The worst case is if all of the faces are visible. That's the worst case. So this face, because right now we are wondering what should we store in this variable here, this parameter, since we need more data. Well, the worst case, all of the faces are visible. And this face needs information about these blocks. This face needs these blocks. This face needs these blocks. And this face needs all of these blocks. So in worst case, we need all of these blocks, all of them. This skull face integer has information for just this 1, 2, 3, 4, 5, 6. This has information for 6 blocks that will not help us for ambient occlusion. This parameter will store information for all of these blocks. So how many are they? So here we have 1, 2, 3, 4, 5, 6, 7, 8. And 8 more below. So 16, 16, 17, 18, 19, 20. So we need 20 information about 20 blocks. 20 blocks, and we can save that information as the same way we saved it for here with a simple integer. How? Well, the curl faces is a simple integer. Curl faces. An integer is like ones and zeros. Like, let's say it's 32 bits, so it should be like 32 zeros. And if the integer is 0, all of these will be zeros. If it's a 1, here will be 1. If it's a 2, here be 1, 0. This should be a 2. And 1, 1 will be 3. So it's binary. And I just play around with these ones and zeros to stick information about the neighbors. So I've coded it in a way where, for example, here, if it's 0, then there's no neighbor above us. If it's 1, there's neighbor above us. And here, let's say it's the bottom. If here is 0, there is no neighbor below us, something like that. We can use the same logic for this other information. And since we need information about 20 blocks, we can do it the same way. We just need to use more of the ones and zeros. But integers should have 32, and 20 is 20 will fit in a simple integer, and I do it this way since less space is taken. So this is my first naive approach. And using this like it will be an integer, and using this integer, we'll give it here into a function just like all of these ones. That's it. And so here where we let's bring out the simple example. And so here, where is it? Here, where we're trying to generate ambient occlusion for this face, we'll start with this vertex. And this vertex, all it needs to know is whether these are here or not, these 3 blocks. And we will have it simplified like this. It will be this simple function. And this simple function needs this data, which it will get from this parameter that will give it here as an argument to the function. And another idea came to me. We could even give this data to the shader directly for each of the blocks. But that will be too complicated, probably, most likely. Yeah, so we'll do it in the CPU, not the shaders. Yeah, we'll do it in the CPU. I think it will be simpler and easier to do. So what's the next step? So we go back. Here we generate. And in order to call this function to generate, we need to give it more information. To give it more information, we are here in this generate. So we need to give it here, which is called in here iron block. Here this generate, we need to give it here, which is called here, which is called in the subchunks. Where is the subchunk? Here. So here, call sites, we need to give another integer like extra inf 20 of 20 neighboring blocks. That's it. So that's the next step. That's the next step. So here, how do we get info on the 20 neighboring blocks? That's it. That's it. We have to figure out this part now. We simplified the problem, we brainstormed it, and we've figured out that in here we need to, the same way we get information about these 6 blocks, the same way we need to do it for 20 more blocks. And even if we figure it out, hopefully it will not slow down terrain generation too much, because every subchunk is 16 by 16 by 16 blocks. That's a lot of blocks, and there are many subchunks. Where is the unity column? Here. All of these are subchunks, and each of them is 16 by 16 by 16. but I don't think it will slow it down that much, since on the visible blocks are not that many. They are not that many. And we'll save up on compute here on this conditional. Just based on the data from all of these 6 neighboring blocks, we'll figure out if we should continue or not, which will save up on the compute, because here in the blocks that are not visible, here there are blocks below us. Here there are blocks below us. For all of these blocks, we don't need to bother finding the 20 neighboring blocks. This will save up a lot of compute. So I don't think it will slow down things too much. Let me think about it. And the first idea that I get is to do a for loop around the block. To do a simple for loop around the block. So we have the position of this block. We can go here and to do a for loop. So first it goes here, all of these, then it goes all of these, then it goes again down towards all of these. So it will be a 3x3 for loop. Yeah. Yeah. Yeah, that's it. Time set day. Okay, we'll do a for loop that goes through all of these blocks. The same way I iterate blocks for calculating the lighting. It's nothing new. I've had to, or when calculating the pathfinding for a zombie, I also need to iterate through blocks. So this iteration through blocks will not be something new. We will be able to reuse some of the previous code. I will just need to avoid this block, these blocks, since we already have information about them. This block, we need to ignore these blocks, and we need to ignore this block, and we need to ignore the block in the center. We need to ignore that block. So this is the shape we need to iterate through. And for all of these blocks, we need to we need to check if it's type air or not. And if it's air or not, to store that information into an integer, like here, int extra info, like to store it inside of the integer. And the next problem will be here when we are like generating this face and we are on this vertex, how are we going to know, like this neighbor, where inside of the integer it is? Since we're like storing it inside of an integer, which is just ones and zeros, and let's say this neighbor is like taken here. So let's say it's like it's positioned here in the ones and zeros of the integer, and it's 1. So how is this vertex supposed to know it should check here? That's something we need to figure out. Yeah, but this is my rough idea. And 1 hour has passed. We can take a quick break. And I'll come back. I'm back, and while I was gone, I found another potential issue. Let's go to the player and increase his speed, movement speed. Let's do it like 20, so it will be a lot easier and faster to demonstrate. So the issue, the other issue with implementing ambient occlusion, like right now, we need to figure out the neighbors of each like block. So here, the issue is like the terrain is not infinite. So I need to figure out what am I going to do with these blocks, because we need to, like, for this block, we'll like check out these neighbors, sure. But what about these neighbors? Here, there's nothing. We need to figure out what to do in that case as well. Look at how fast it moves. Yeah, we need to figure out that as well. Let's get back to the player, give it 7. So, what we figure out is we need to iterate and get information about all of these neighbors. So, let's do that. In the subchunk here, we need to iterate through the neighbors, but before that, let's see here. We need to make a conditional if the block is completely hidden away to skip all of this extra work. And what will be the condition? What I was thinking is if curl size is 0, to continue the for loop. But was it like that? Let me think about it. So here it's 0. And here, if let me think about it. What does it represent? So if this is just zeros, what does it represent? Because I store, for example, here, I store information, the block above us. And I'm not sure if, like, there are two options, if this is 0 or 1. And I'm not sure what 1 represented and what 0 represented. So if we should not draw the face, the top face, we call the top, which is 1. Okay. So it's like this or this. So the end result will be, I think, this. Yeah, it should be this. And this is if we should not draw the face, the top face, and we should not draw it. We shouldn't draw it if there is a neighbor there. If there is a neighbor. So if there is a block above us, we will not draw it. Let me think about it. And I want here to continue. I'm trying to think this part. I have to decide what this should look like for when there are neighbors on all sides. So here, what does this represent? This information about the block above us. And here it's 1 if we shouldn't draw the top face. So we shouldn't draw it. It's hidden. So there's a block above us. And here, block above us, block above us. So all of these neighbors, they go up to 32. They go to 32, 32 in binary. They go up to 32 like this. And so this is 1, this is 1, this is 1, this is 1, this is 1. So in this case, we will continue. That's it. So we need to convert it to an integer. Binary to decimal. Convert, so 63. 63. So if it's if it equals 63, but can I do it in like binary? So can I do like this? And how can I represent binary? Java binary number. How can I represent binary? 0b. Yeah. So if all the neighboring blocks are there, we'll continue. But that's not true, actually. Actually, that's not true. That's not true. This is another problem we found. This is another problem. Why that's not true? Because with leaves, yeah, with leaves, look at how there are blocks around it, but we're still rendering it. So we shouldn't stop continuing. We shouldn't like do a skip of the for loop. The only thing we should be skipping, if there are blocks around us, the only thing we should be skipping is the calculation of the ambient occlusion. Here. That's it. So if just one of these blocks is empty, if just one of them is empty, so like if just one of the faces we have to draw, we will check for all of these blocks. And we need this conditional since there are many blocks, and if for each of them we need to iterate for 20 extra blocks, that will be like so much of waiting time, and it's not needed because for this block that's hidden away completely, we don't need to iterate 20 blocks. But for this leaf, just because it's hidden away, it doesn't mean we need to completely stop work on it, since we still need to generate the mesh data. So yeah. So now here we need to iterate 20 blocks. We need to iterate, and how are we going to do that? Well, I have an abstraction which is called position details. And I need the current position. I have an abstraction that just has the coordinates of the current block, of the current chunk. It has like just check origin, block type. It has all of this helpful information, and it has helpful member functions that allow me to like go up for example. And if we are crossing a chunk, it will on its own use the data of the other like neighboring subchunk. This is how I iterate blocks. And so we're iterating here. Let's start with, for the iteration, let's start with the position of the current block. Let's start with the position of the current block. And how do we get it? First thing I'm looking for is if we already have it. Do we already have it? Get block data. Do we already have it? The current position as this class of position details? I think not. Yeah, I think not. So we need to create it. So new position details. And here we need to give it data. New vector 3f. And what should be this data? Because it has here of, yeah, okay. Chunk origin, get chunk origin at global position. So we should give it global position. So we need to give it like the X, Y, and Z. This is local. We need to add the position of the chunk X, or like we can do like this. We can just add the position of the, oh, it's a vector 3i. So we can do here 3i. No, we can do, okay, let's do it like this. I hate Java, but I can make a lot of progress with Java, so it's a mixed bag. I have a love-hate relationship with Java. I prefer using C++, but I have a lot more progress using Java. So we have the current position as this abstraction position details. And we need to go, like we are here, we need to go up. We need to go up. So position details go up. And it returns the result. Yeah, it's a problem that it returns the result and doesn't change the result is new position details. We change the result and we return the result. I would prefer right now to not change, because this will create like this will create another position details, another class. I don't want that. So let's see now. Do we have alternative? Do we have alternative? Get block after looked at quote. Change block ID. Go up. I don't want that. I don't want this. Get block. I don't want this. I don't want this. Go towards direction. No. Go down. This is the same. This is the same. This is the same. Go west. Distance to set block. Update block. Get pathfinding. Okay. We can implement a function inside of it that will give us the 20 blocks, 20 neighboring blocks, since the only abstraction we have is function like this, which creates a new position details. Or we could create functions that don't return anything and change the current position details. But that will require us to create 1, 2, 3, 4, 5, 6. That will require us to create 6 more functions. How do we do it here? We have current. Get blocked. Oh, okay. We can do it. We can do it like this. The same position details to equal to the new one. We can do it like this. So let's do it like this, and if it will cause an issue, we'll figure it out. So we are at this position and we need to iterate through all of these blocks. And to do that, my idea is to go up and then to this corner. And from this corner to go like this, to go like this, to go like this. Do we have better approaches for iterating through all the blocks? What is that cow doing? Look at it rotating. What are these cows doing? Weird. So do we have this position. We need to iterate over these blocks. And my idea was to go to this corner and from here to iterate these blocks, then go down and iterate these blocks, then go down and iterate these blocks. Do we have another approach? Do we have another approach? Well, I think our iteration through the blocks should fit how we store them. It should fit how we store them inside of the integer that is like currently called extra information. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This should be the integer probably. And we'll use just 20. We'll just use 20 integers from the 32 availables. We'll use 20 of the bits from the 32 available. I assume they're 32. So how are we going to store the information? Because we have 20 blocks. And where should this block be stored? Here. Like, which should be this block? Which should be that block? Because currently we're here. And okay, we can start going up. And if we start from the corner, this corner will be this block. And we can go clockwise. This block to be this block. Like this clockwise. So it will be like 1, 2, 3, 4, 5, 6, 7, 8. So these 8 blocks, 1, 2, 3, 4, 5, 6, 7, 8. These 8 blocks to be these blocks. And then these 4 blocks to be these 4 blocks. And then these 8 blocks to be these 8 blocks. Yeah, this is one approach. This is one approach. Do we have an alternative? Because if we are going to try something else, this is the time to try it. Because once I start one implementation, I don't want to make changes. I want, once I start, to continue like that, to not have to make changes. Because it will be a big hassle. So, where we start? We start from this block. We start from this block. We could, instead of going up, we could go to the sides, but it's the same thing. Or my other idea is to organize them based on faces. So the top face will have all of this information. So when we're rendering the top face, we have all of its information at close by. The problem is, for this face, now we have to store all of this information, but this information is already stored. So how would that look like? So the top part is the same. We can start from the top again. It's the same 8 bits. It can be 8 bits. And now let's say yes, and we can simplify it by going to the bottom and then another 8 bits. Then, yeah, here another 8 bits. The idea is this to be the top side neighbors, this to be the bottom side neighbors information, and all of this to be the other sides. This side, this side, this side. The issue is that, let's say like this side will be these 2 blocks. So like this will be top, bottom, and these 2 will be like the north. And let's say this is the east. The east, the only information it can, like, the only new information is this block. So let's say this is the east. And let's say this is the south. The south has only this new information. So this is the south. And the west has no new information. And so how will extracting the information look like? Well, if we are rendering the west side, we need to have access to like 1, 2, 3, 4, 8 blocks. We need to have information for 8 blocks, all of these 8 blocks. And how do we have access to them? Well, the top 3, we can extract them from here. The bottom 3, we can extract them from here. But now, how do we extract these ones? Because they could, like, this one can be from here, and this one probably from here. That's too complicated. Okay, so this iteration doesn't work. The other approach is like this. Again, top and bottom, and this to be the sides. Yeah. So here for this phase, we need these three. So that will be from the top. We need information for these three blocks. That will be from the bottom. And we need these two, which will be from here. That's it. That's it. So this is one way we can organize the information. So how will that change the iteration? So we have this position. We can go up and go through all of these. Okay, just for the top, how are we going to organize the top? Since this is the top, it's like 8 integers. It's 8 integers. It's 8 integers. What will be the first one? This is important. Because if we're rendering this site and we need these 3 blocks, we know for sure it's the first 8 bits. But where inside the 8 bits will be these 3 blocks? And let's say this is the west side. This is the west side. Because if we have them to be like this is the first one, second, third, fourth, fifth, sixth, seventh, eighth, and we're on the west side, how is the west side supposed to know these 3 blocks are the like 5th, 6th, and 7th? That will not be helpful. So, we could organize it first going through the corners. So this corner, we could go through like this, like north, south, east, west, and then these blocks, the east blocks and the west blocks. So when we need these 3, it will be let's say it's 4 by 4, and let's say the first 4 bits is these blocks and the other 4 bits is these blocks, if they are there or not. So for this face, we need, for this vertex, we need these 3 blocks. Yes. So we need from the top of the first 4. So we need this block. This block is from the top, so the first 8 bits, and it's from one of these, so the first 4 bits. And let's say like west, let's say we start from north, south, east, west, so it will be the last bit, and that's it. And here we need the corner, so it's the first 8, the second 4 bits, and let's say we do north, south. So first 2 is north, second 2 is south, and then east, west. So is this last one. That's how we can find it. And we need this one, this block, which is from these 4 corners, which again is like north, south, east, west. So from here, north, south, then east, west, this bit. So we will care about this bit, and this bit. That's the system we'll use. That's the system. So how are we going to store this information? How are we going to iterate knowing all of this? Well, we'll have this position, and from here we'll go to the top, and then we're in this block, we'll go north, south, east, west, and then from here we'll go to the corners, like the north corner. No. We'll go north. We'll go north, then east, west, then go back, then south, then east, west. And we'll do the same thing below us. And then for here, we'll go for these blocks, we'll go here, north, then east, south, then we'll go east, west, and then we'll go south, east, west. Yeah, we figured it out. That's how we're going to do it. That's how we're going to do it. So here we have let's call this origin, like current starting block. We'll have the starting block. Now, extreme, ambient occlusion neighbors. That's how we'll call the where we store all the information for the neighbors. Now, here we'll go for the top neighbors. We go to the top neighbors. And how are we going to do that? We need to go up. And I need to have this starting block as it is. I don't want to change it. So we need another position details, top blocks. We can call it just top block to be the starting block. Go up. We go up. Now, we need to have something like this. We need names. This called top, from where is it coming? Yes, it's an integer. Damn it. I'll have to think of names. Oh, and we found another huge problem. We have another very big problem. I'll demonstrate it very easily. Look at the lock. It gets all of its neighbors, sure. But what happens, and this is the top side, but look at now. We rotate it. Now it's rotated. And this is an issue. Since this is a very big issue. And I haven't these complicated things. Even though it complicates it, the logic is still the same. We still look for the top neighbor, all the other neighbors. Yeah. It's still the same. But when I rotate it, I need to... Because right now we need to... Because we're iterating through the blocks. And we're at the top block, and we will go... Top block will go north, like go north. We'll go north and we'll check the type of the block, if it's air or not. And if it's not air, if it's there, so this is the top, this is the, how was the, let's say it's here, this block. Let's say this block is like this in this bit, and it should be like it should be like this, and here if block type is like air, like something like this. If it's air, so it should be like conditional, and here like it should be a 1, something like that, because its position is here. But if we have rotation, like yeah, we'll ignore rotations. We'll ignore them. I think it will be easier to solve them after we have, without rotations, the solution. So this here, where I put 1 here, it's good practice to use names. It's good practice to use names, just like I have curl top, curl bottom, which is like 1, 2, 4, 8, 16, 32. I need to create 20 variables, and it's best to be like enum, public static enum, ambient curl, no, first like I declare it. And here it should be the names. We have to think of the names. So top, north, then top south, then top east, then top west, then top north, east, then top north west, then the same thing, but for the south. And this is the top, and now the same thing, but for the bottom. And then for the sides, so north, northeast, northwest, then southeast, southwest, and here I need all of these to be like numbers like these, to be binary. Enum change values. Enum. Yeah, enum. Enum needs to have a field of integer. Enum needs to have field of integer. Yeah, like this. So like this. So public final int value, and then private ambient curl int value, and then this value equals value, and then here this will be one here. Let's just copy it, all of them to be zeros just for now. Like this. Like this. So here, this will be 0. This will be 1. This will be 1 here. So this is 1, 2. This will be 3. This will be 1, 2, 3. This will be 4. Then 1, 2, 3, 4. This will be 5. 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5, 6. I can make it easier. This. Then like this. Like this. Then like this. Then like this. Here, here, here. And then here, 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 here. That's it. That's it. And I need so here it should be, all of this was just so we can do here ambient curl, and then this is top north. That's it. Value, right? Yeah, value. That's it. Or mask, we can call it mask. 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 We can call it mask. This is top north. Can we do it? Is it? Yeah, we can do it like this. So, so from the top block, yeah, we start from the top. We go north. But this block type, I'm really concerned about it since I don't think we updated. I don't think we updated, and when we iterate, I don't think we update what's the actual block. I only update the positions. And I need to be right back. Yeah, I'm back. Now, what we are looking for is the block type. To check if it's of type air, but that's an issue. That's an issue. We need to get the block data. Yeah, we need to get the block data. Get block data and to check the ID. If it equals here. Okay. So now we check if it's air. If it's air, if it's air, like when should we add the one? Set the flag. When should we set the flag? If it's air, there's no neighbor there. There's no neighbor there. Here, all neighbors are present. So if there is a block, I usually set a flag. And so here, if it's air, yeah, this should be 0. If it's air, we do nothing. But if else, we use the flag. So now we have to go over all the blocks. So these ones are the top, and these ones are where was it? These 4 blocks. These 4 blocks. So the north, top north, and now top south. We need top south. We need to go top south. So the same thing as here, but for top, but go south. And here top, south. That's it. And now the same thing, but for top east, and here top east, and then again for west, and here west, and that's it. We are done with these bits. Now these bits, which should be how? Let's change this to north, and then let's save the reference for them, because yeah, let's save the reference for the north. This is like top, and this is top north. So here north, let's save this reference, and let's save the reference for top south. South. And so this is just the top, and this is the top north. This is the top south. I saved them because now we'll need it for the corners. And I'm wondering, will we need them again for the bottom ones? So these are simple. Like, we got the information for these, and now I'm targeting these. Since I'm saving the reference to this, from this we'll just go east and west. Sure, like that's fine. But and for the bottom, we'll do the same logic. And then I'm wondering, like, if we save reference, maybe to save reference to all the corners, because we can just go up from there. Yeah, we may need to save reference to the corners. Okay, we'll think about it later. Now, think about it. Yeah, now we need these ones. We need these ones, so we'll reuse the top north, and we go east. So this is top north east. Then we go west, and here is west, and then the same thing, but using top south. And here south, that's it. Now we have information for all of these blocks. Now we need information for the blocks below. We'll use the same logic. bottom neighbors. This is the bottom, so bottom, bottom, bottom. And oh, we need to change this to the using the top reference, and here to use the bottom reference. Here it should use bottom north, bottom south, and here bottom, bottom, and here bottom north, bottom south, and here this should be bottom. Bottom, bottom. That's it. So now we have information for these blocks below, for the blocks above, and now we need these 4 blocks, and we'll be done. We need those 4 blocks. Site neighbors, they're just 4 blocks. And these are the top corners. So from here, from each of these, we just need to go below. And so we will save reference to them. So top, north, east. Top, north, west, top, south, top, south, here, west. So here, this is west, and this is south, east, west, and let's reuse them here. East, west, because now we can reuse them. So here we just need to go down. We just need to go down. And here it will be without these parts. So this will be just northeast. North, yeah. That's it. We've went through all the 20 neighbors, all of them, and we've stored the information, I assume, properly. And now we need to give this information. We need to give this information. Get positions. Here. We need to give it here. And here, int ambient occlusion neighbors, which and the problem is I override this everywhere. So it's not just iron block. Where is it? Like here. And here it says there's an issue. I have to change it like this. And I'll have to give it here. And I have to change this. And this get positions is like everywhere. Not only that, but for this and this and this. Yeah, I have to give it here. So for the generator. Yeah, okay, let's change here. Int ambient, what do I call it? Ambient occlusion neighbors. Like that. And here. Oh. Yeah. I need to rewrite more. Yeah, this will be a tough one. Current neighbor. Yeah, this will be a tough one. Template. Do we have... here's the issue. I have this generate method, and I have two versions of it. Here uses integer call sites, here integer call sites and a limit. And I also want to add another integer, the ambient occlusion neighboring blocks data information. But the problem is I need to add it here and here. Okay, it's not a problem. It's not a problem. It's not a problem. Here int like this, and here like this, and here like this. That's it. And here we have to give it here. And here we need to do int. And finally, we have the information for the neighbors when we are generating the sites. And it took us just 2 hours. We have to run it to see if everything is running fine. But before that, we'll have to solve like compilation errors for sure. So this. So before it was like this. We need to find all of these occurrences and change them. So edit, find and replace I need. Replace in files. I need to replace it with this thing. I need to replace it. Find, replace in files with here. Integer like this. I need to replace it in a couple of places. Yeah, should be it. Replace. And this generate method, let's find it. We need to replace it as well. Find replace in files with like this. Yeah, like this. Replace all. And then we want, there's another one, I think. Find replacing files. Okay, it's like that. And I need it replaced like this. Replace all. There. Can we run it? Let's see if there are. Oh no, there are issues. I hate it when there are issues. Hopefully it's a simple issue. Null pointer. Oh. Null pointer, yeah. The issue we talked about is the end of the world. Because in the end of the world, it cannot find a neighbor. And in that case, it's null, I think. Position details. Because I try to get block data. And yeah, when I try to get block data, it can return null. It can return null. Okay. So. Oh, come on. Yeah, get block data. If it's the end of the world, it returns null. And that's an issue. We can extract this into a function and the function to handle it. Yeah, we can extract it into a function. Can we make a function declare a function inside the function in Java? It will be more organized like that. Java function within function definition. Because I'll just use it there. Cannot do this. Okay, I'll not bother. We need a function. So it will be called like private. What does the function need to do? Handle. Okay, void. Or like int handle ambient occlusion neighbors mask, and it will get current ambient neighbors data, and in the mask and the block data, the current block data. And so inside of here, so we have to return so this or this. Here, this is the mask. And if block data ID, but before that, if data is null and like that. If the data is not null and the block is of type air, And if the block is of type air, we have it as 0. But if it's null, or if it's different than type air, we will mask it. We'll have the mask. So in situation where, like here, this is out of bounds, by default, it will assume that there is like something there, which is like, let's say it's fine. And so here, I'll need all of these will be just equal signs. Or to just have the mask itself. Yeah, just the mask itself. So I don't need this. And I'll return just this. And so here, I need to give it the block data and the mask. And this will be annoying to handle. And what's the issue? I've moved them around, so like this. Here, we've made the change. So all of this needs to look like this. And this will be really annoying to handle, but this is the perfect use case for an AI to like save up time on like formatting all of this. You don't need any using of brain power. This is only like you have to, like the instructions are very simple. Copy, like instead of using this to call this function by giving it the block data and the mask. That's it. The instructions are very simple. I'll ask so this is the info. Use the function with the data and mask. For the other cases, keep thing like mine. First example. This is the only use case for an AI to just to follow simple instructions. I just wanted to call this function with the block data and the mask. That's it. And I think it's ready. Top north. Yeah, and that's it. That's it. Done. We're done. That's it. So the game is running like before. The only difference is now for each block we have information for it of its neighbors. That's it. And it didn't add that much waiting time when generating all of this. And that's perfect. Nice. So let's actually do a commit. Getting 20 neighbors information for each block for ambient occlusion, and then we ambient occlusion, git push. Perfect. And now and now we need to use that data when we, where is it? We need to use it for the generators. Where? Okay, get positions. Okay, let's go for iron block. Generate. Now, here we have ambient occlusion information. Yes. And here we need to handle it for each of the faces. So I have an array for all of these. And I think I need an array for the each vertex, the ambient occlusion data. So for each vertex, it will be just integers. It will be just integers from 0 to 3. So public array list integers ambient data array list, and then we need functions so here it will be conditionally at face ambient data, and it will be called from here. What's this start? What's the start? Oh, from which vertex to start? From the unit cube, but we don't need it, so we don't need this start. We need these arguments, but we need the data. We need the data. Ambient data. Ambient data. Int like this. And here we create the data for ambient occlusion. Here we do it conditionally for each face. Conditionally for each face. And conditionally for each face. And how are we going to do that? Here, this means, if we are here, this means the face will be rendered. So we need to generate the ambient occlusion data. We need to go over all of the 4 vertices. All of the 4 vertices. South, north, west, east, top, bottom. How are we going to do that? Well, it's a simple call of this code. So we need to go over 4 vertices. The face has 4 vertices. Let's go over just one of them. The vertex 0. Then we need to go over vertex 1, vertex 2, and vertex 3. We go over 4 vertices. And for this vertex, we need to get an integer or like ambient data. We need to add the integer, which is created from private int calculate ambient data, and it needs to be like this, and let's say it's like boolean, and to return this is it. And here if what if, but this should be ones and zeros. This should be ones and zeros. If this is 1 and if this is 1. Yeah, and here we need to add like this, and here we need, for this vertex, it's 3 neighbors, if they're there or not. And we have that information here. That's where we are now. If we solve this, we'll be almost done, since we need few extra steps. We need to send that data to the shader, like we need to store it inside of the mesh and to send the data to the shader. We need to send the data to the shader, and we need to edit the shader from the resources to handle this data, this ambient data, which is integers from 0 to 3. Let's think about it. Let's think about it. Now, here I need, for each of the 4 vertices, I need to give information for their neighbors as integers, the 2 sides and the corner. And so let's say we are looking at face, let's say this is the north face. And let's say we go we go like this is vertex 0, 1, 2, 3. And if we go to the top, this to be vertex 0, 1, 2, 3. Sure. And so here, but how are we going to handle this? Because here this function is called for each of the faces. How are we supposed to know what is vertex 0? And how are we supposed to know which are the 3 neighbors? We can do, depending on the face call, we can do a switch. We can do a switch depending on the face curl, in case if it's north curl, culling, case north curl, and break, right? Cannot constant expression required. Constant expression required. Do I change this somewhere? Fine. Oh, no, no, no. Oh, no, 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 no. Oh, it's different. God damn it. It's different. Yeah, the culling, I think these these integers are like just like 0 or -1, and if they're minus god damn it. How do we do it? If face curl is positive, if it's not negative, and face curl and curl faces. Oh, I see. So if okay, so okay. So I need to check where. How do I check if we're working with the these ones? Where do I set them? Yeah, here. Subchunk default north, curl north. Okay. So here case north, and then if we are working with the south, and so here for the north, what is vertex 0? We can simplify. This is the simplest way to do it. It's more cold, but it's the simplest naive approach we can use. What is vertex 0 for the north? Vertex 0 for the north is top left, like top east. No, is this west? This is south. Okay, east, west. So left is west. So this is west. Let's say top west. West. Okay, let me see now. I need to figure out the directions. So this is west, south. Okay, this is north, west, east. So this is west, this is north. So like this. Yeah. So this is north, south, and this is west. And how do I... This is west, this is north. So this is north. And this is west. So this is east. Yeah. Time set day. So I want here. Yeah, so this is the north. And this is the east. So the top east is a vertex 0. And so which are these 3 blocks? Man, this takes so much time. This should be side 1, like side 1. This should be side 1, this is side 2, and this is the corner. So from ambient occlusion neighbors and. So here should be like sub chunk ambient curl. And now which block is that? This is the, which is this block? This block is now this is west, north, south, west, east, west. So this is north, east. Yeah, this is northeast. And actually, is this actually vertex 0? Yeah, I remember that I should do it the same way I create the vertices, the same order. So it depends on the unit cube. Yeah, the north. This is the north. So it should be in this order. It should be in this order. And actually I can create an array just like this one, where each of the positions here has the right mask, a copy of the mask. Yeah, that's what I'll do, but we need a quick break. Now we're back, and I had the idea to create the array of integers that are just the masks, and it to follow the same order as the unit cube. The same order, and to follow the same order, but I was thinking here I'm just creating like this separate field, and I'll send that separate field to the shader as integers, and I'll handle the integers in the shader. But as I thought about it, I can just directly reuse the colors and modify the colors, because the ambient occlusion is just a change of colors. Like this, it just changes the colors. I don't need to create a separate array. I don't need to do that. I don't need to do that. And so here, Hmm. Hmm. So here when it's add color, I have the south color. Yeah, for it adds it 4 times. So here, where I add colors, I need to add the logic there. I need to add the logic here. Yeah. That's what we need to do. So I need to give the data. The ambient occlusion data, I need to give it here. And now I don't need this. And here, I do integer like this. And then, here, I'll create something like this. But it will be of type integer unit cube mask. Let me think about it. Like, what was the idea? It was for example, we are working with the north, and for this vertex to have the right masks. But this is only one vertex. For this one vertex, we need 3 integers. We need 3 integers. Let me think about it. Okay, we can try. So for the north, what is this vertex? So this is the north and positive on the x. So the north and this is north. Yeah, this is north. And towards positive x. But it's 0 on the y. So it's actually this bottom vertex. And here, this is this vertex. So it starts from here, then here, then here, then here. So it's like here, 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 and here. This is the order for the north face. And so for here, we need, let's say this is side 1, side 2, and corner. We need these 3 blocks. We need a mask for this, this, and this. And so here, we will have this, this, and this mask. So this is the bottom. This is bottom north. Yeah, this is bottom north. And this is north east. So we need subchunk ambient cool bottom No, bottom, north, east. Mask. Like that. And then we need northeast, and then we need bottom, north. We need, no, it's bottom north here. Yeah, it's bottom north, and here is just northeast. Yeah, northeast, and this is bottom northeast. Yeah, that's it. And now for this vertex, this vertex and this vertex. Now for this vertex, this is here. Like this is the north. Like we're at the north. Minus z. Yeah, we are at the north towards negative z. Sure. And this is positive x. This is positive x. But here it's towards the negative x. And towards negative y. So it's this vertex. It's this vertex. So for this vertex, which one is side 1? Here, which one was side 1? Bottom north. Bottom north. I said this is... This is side 1, side 2 for this vertex. And for this, which one is side 1? This or this? Is it this or this? For how did I figure it out for here? It's... I was looking at like this, and I said like the left is side 1. That's what was my thought process. To the left of the vertex, and here I decided I think this is the side 1. I just have to visualize it. Like this, side 1, and this. Yeah, this is side 1. So this is north west. Yeah, this is northwest. This is northwest mask, and this is side 2, which is bottom north mask, bottom north, and now the corner is bottom north west mask, and that's it. Now the other vertex, which is this one, and this should be side 1, so this is top north, so top north mask, and this is northwest mask, and this is top northwest. Top, what happened? And this is top northwest mask, and now here is this, which is side 1. This should be side 1, which is northeast mask, and here it's top north mask, and this is top northeast mask. And now we need this, we are done with the north side. Now we should do the same for the other sides, and just by looking the vertex coordinates, can we more quickly figure out these names? So let's pick the south side. Let's pick the south. Let's pick the south, and here, let's see if there's a pattern here, so we can make this process a lot faster. Here it's 1 0 0. Here it's 1 0 0, so it's like this 0 meant that we are always working with the north. Here north, north, north. So if this is 1 like here, the difference is that here will be south. That's the difference. Here it was 0, so bottom, bottom. Here is 0, bottom, bottom. Here is 1, so top, top. And here is 1, so it's the east. And here is 1, so it's the east. So my idea is, can we copy all of this? So 1 0. We'll copy it blindly, and we'll do a check. If the check is correct, we'll do the others without doing a check. 0 1 0 1 1 1, and now supposedly we just need to change north with south. And we need to check if it's correct. That's it. Now the south should be done. So let's check it. Where's the south? This is the south. This is the south, and this is 0 0. So 0 on the X. There is the east, positive X. So 0x and 0y. So this is vertex 0. And for there, this should be side 1. And is it correct? So southeast, southwest, where is west? There is west. So it's saying that this is side 1. And I think this should be side 1. What's the other one? Bottom south and bottom southwest. It's an easy change. I can just swap them if that's the only issue. And then for here, what is side 1? Bottom. It should be this, so we swap them. And for here, it should be this one, the top. And for this, it should be this one. This one. Okay. The south is done. And now the west. Man, this takes so much time. Now the west. The west. The west. Let me think about it. So zeros. The west. Where's the west? This is the west. So we need, and what do we have? All zeros. So top and z is 0. So this is positive z, negative z. So 0, 0. Yeah, here is, this is vertex 0. Vertex 0, so we need, so we're working with the north. And we're working with the north and the bottom. For this one. With the so the bottom, where are we? Bottom, yeah, this is the bottom. West. Southeast, north. This is the north. This is the south. So north, south, west. West. Okay. This is the west, north, negative z. Which is side 1? This. So bottom. We need bottom, west, mask, and then we need west, north. We need, oh, it's based on north and south. Based on north and south. North, north, north and south. So northwest, west, northwest, northwest. Yeah, so it's northwest. Oh my god. And then bottom northwest. That's it. And then here on the positive Z is this. And this should be side 1. So So this should be side 1, which is toward the south. So south west mask. And then bottom what? Southwest. And then bottom, it is just bottom west. And then bottom southwest. And here it will be, oh my god. And here it will be 0, positive Z, positive Z. This, so top west, west mask. And then this is toward the south, so south, southwest, and then top southwest. And here it's, and here it's this. This should be side 1. So northwest mask, and then top west, and then top northwest. And that's the west. We will try to do the same for the east. For the east, 0, 0, we'll just copy them. I assume it's symmetric. 0, 1, then 1, 1, and then 1, 0, and then we need to change it from west to east. West to east. and we need to check it. So this is the east side. This is east, and vertex, the first vertex is the bottom, and on the Z positive. This is vertex 0, and so it should be bottom. It should start with bottom. Here it's bottom, here it's the other way. And then the top. And for here, the other way. And that's it. That should be it. And now for the top and bottom. Top and bottom, we are close to the end. Top and bottom is X and Z. X is towards negative and Z towards negative. Towards negative Z, towards negative X. So it's this. This is vertex 0, like this. This is vertex 0. Towards, so, and this is side 1. So towards negative X, west. West. So it's top west mask, and then top north, and then top northwest, top northwest. And the next one is positive X, positive Z. So this was negative X, positive Z. Negative X, positive Z. This vertex. So, yeah. South and west. Oh, so it should be south. Toward, I got confused. Let me try again. So it's, the first is positive Z. This is positive Z. And negative X, which is here. So this is it. And this should be side 1, which is the south. Yeah, I got it wrong. Should be the south. And west. And then southwest. That's it. And here is toward positive Z, positive X. So this is side 1, east. So it's the same. East, south, and then east. That's it. And then positive X, positive X, negative Z, positive X, negative Z. So it's north and then east. north, north, east, north, and then here both negatives, negative x, negative z, west and north. West and north, northwest. And now the bottom, this is the final part. The bottom. Now the bottom is negative x, negative z. Negative x and negative z, and negative x, negative z, and so it's north and then west. North, it's north and then west, and here it's bottom, north, west. That's it. And then positive x, negative z. Positive x, negative z. It's east and then north. East, north, northeast. Then both are positive. X is positive and Z is positive. It should be southeast. Should be southeast. South, southeast, 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 and then both negative. X is negative, Z is negative. Northwest. Wait a minute. No. Z is positive. Z is positive and X is negative. So it's west, south. West, south, south, and that's it. Oh my God. And then unit cube masks. Now I'll need an integer, just like here, the start. I'll need a start. I'll remove this and conditionally add color. I'll need a start here as well. Yeah, I'll need start as well because, and now I need to give it. So for the south, where do we start? The south is 0. The south is 0. Now the north is 4 times 3. because it's like it should be 12. So yeah, 12. The north should be 12, so it's exactly the same numbers as here, but times 3. Then by 12, then 3 by 16, and then 3 by 20. 36, 48, 60, 24, like that. And now for the color. Now for the color, I want to do it like the faces. Here we do a for loop. And for adding the colors, we'll do a for loop. And let me think about it. We have a for loop. So we need to do it 4 times, like for int I equals 0, I less than 4, I plus plus, because we have 4 vertices. And for each of the 4 vertices, we need to do it let's do int side 1 equals, we need side 2 and corner for each of the vertices. Side 1 is ambient occlusion neighbors and unit cube masks from the start plus I times 3. And yes, plus 0. Plus 1 and plus 2. Like this. And so we calculate ambient value equals calculate ambient data, side 1, side 2, corner. We have the data, and now we need to push colors. Before we had just this, and now it needs to be to add to it new vector 4f. We need to add. Now how much do we need to add? Since we get a number from 0 to 3 is nothing, 2 is a little bit, 0 is the most, I think. How does he calculate it? Zero is nothing. What should be the most ambient occlusion? We can do it from an array. private static ambient values float array ambient values to be equal. Now if it's 0, it's nothing, because we are adding, or we should multiply. I think we should multiply. Yeah, multiply. So ambient value, if it's 0, maybe 1 minus ambient value. No, but ambient... yeah, I was thinking to do it like ambient values, like this. And here, if it's 0, we multiply by 1. We don't make changes. If it's 1... oh no, 0 is the most. 0 is the most. So 0, 1, 2, 3. So here it's 1. This is for if the ambient value is 3. It will multiply by 1, which will change nothing. Here it should lower it a bit. I want to see something else. I was doing something like this. Color. I had something like this. Yeah, fake lighting. 0.7, 0.8. So yeah, but it will change the alpha as well, I think, which is bad. I don't want to touch the alpha. Fake lighting. Yeah. Ambient data, ambient values. So the closer to 1, the least of a change we do. So 8 and 7, let's say. And then vector 4f color equals new vector current color. We multiply it. We multiply current color. Let's set the alpha to 1. X, Y, Z, W to 1. And we add it to colors. And now the moment of truth. After so much code and calculations, we have to see if we've done something. And it failed. That's expected. Ambient value minus 133. Ambient value. So side 1, 2 and corner are probably not ones and zeros. Yeah, most likely. Side 1, 0, 0, 0. So we will make it conditional if ambient value is more than 3. New game. So this is 4. This is 0. This is 0. Yeah. So why is this 4? How much is this? Quick evaluation. Out plus click. Out plus click. 4. Value 4. Okay. So this is value 4. And this the whole thing here is 4. Let's see why. I just want to copy this value. Copy value. Decimal to binary. Convert. It's this thing. And this is 4. So let's convert that to binary as well. This is 4. So 100. 0. Yeah. So I managed to extract it, and the result was the mask itself. The result was the mask itself. And I want it to be 0 or 1. I want it to be 0 or 1. If I could do so I have the binary zeros and ones, and I have the mask. And I have the mask. And I'm doing let's look at binary operations. Java operations. Yeah, it gives yeah, that's what I need. But the OR gives all of these. XOR gives the difference. Gives the difference. Complement, no. So we have, let's say we have like this, and where is it easier to see? Here. Now, if we have this and this, it will result to this, which equals to 4, which is a mistake. Well, it's correct. It's doing it what it's supposed to do, but I want it to be like either 1 or 0. If we do this or this, it will give this, which again is not what we need. If we do, let's do XOR. XOR will be their difference. It will be their difference, which is it's 0. Okay, what if we do, if it's a different mask? So this mask, or like if it's this mask, their difference is this, which again is not what we're looking for. Java pack unpack data. How do they do it? How do they do it? Okay, let's simplify it. I just want this to be over so we can end it. What we can do here is if this equals to this, and then to make it into an integer. Okay, we can do it like Boolean. Can do it a Boolean. If this, no, where have I done these kinds of tests? Face call if it equals 0. Let me think about it. Yeah, if I just do it like this, so we have, let's say this, and 100 and equals 100. If it equals 0, so this will be false. And this will equal to 0, which will be true. And I want the opposite. If it's different than 0. And here, how to convert them to integers? Java boolean to integer. Okay, I can make the function accept booleans. Boolean, and then int site1 to equal 1 0, int site2 corner done. Finally, now we can see if something changed. What? What? Oh my god. What happened, man? What happened? What? At least we are targeting the vertices properly. We should be ignoring foliage for sure. But mm, hmm. These blocks, these vertices should be getting changed as well. They should be changed as well. Here the foliage should be ignored. The foliage should be ignored. Interesting. Yeah, we can do it even now. Let's even check it out in Minecraft. Yeah, the foliage is ignored and and is it the same with glass? Glass? Yes, I think. Yeah, it's the same with just transparent items. So, yeah, this was good progress. So, where do we get the data subchunks? Subchunks. Handle if data block data block data, what does it has? It has the ID, but it doesn't have if it's like transparent. Get block data. Get block, which is get block data. Okay. We can get block equals data get block, and then if data is null, we return either the 0 or the mask. Let's return 0. Now, here if block is air, if is transparent. Let's test it like that. Now foliage should be ignored, I think. Yeah, foliage is ignored. Foliage is ignored, but the foliage itself has ambient occlusion. It's not an issue. Here, the leaves have ambient. We'll see if it's an issue. Let's see now. Now here. Here, these sides are missing. Yeah, we are very close. Here, this corner is this. Yeah, this corner is perfect. This corner should be... Yeah, we need some slight changes. We are close. So the top is working well. The sides, let's do like that. Yeah, top is working well. I want to see the bottom. And bottom is not working properly, I think. Let's go like this. Like this. No, I think, and bottom is not... Yeah, bottom is not working. Bottom is not working. What's the issue? What's the issue? Yeah, I'm not worrying about the color that is white. We can easily make it, instead of white, to be darkness. But now that it's white, it actually makes it easier to see what's happening. And I'm wondering, why is the top like this? Why is the top acting like that? Where exactly is the issue? Is what I'm wondering. Here the top, here it has some kind of a value. And here not okay. Here the top, this vertex has a value. This vertex has a value, sure. Here this vertex has a value. So this triangle is perfect. But here it should be just... Oh, I think it's like this triangle, this, and this triangle here. The ordering. Here is perfect, and here it's perfect. But here, I think the ordering needs to be a bit changed. But this is a minor issue. What I'm most concerned is this face. So here, the value, it must think it's 0 or like 3. And it's 3 if there are no neighbors. So it's not finding the bottom neighbors. So is the issue from the mask or from when I get the neighbors? I'm not sure from where the issue is coming from. Only the top and the sides sometimes work. So if we have here, so this vertex looks for so this vertex, what are the sides and corners? It would be this and this below and the corner there. So, but it has, this vertex has corner here, and it has corner and side. It has side 1 and corner, which should increase the value here. Here it should have whiteness. Here as well and here as well. And it's not having it. And it's for the bottom. And where is that mistake happening? But we are really close. We are really close and I haven't eaten anything. Um, hmm. Here. Is it here the problem? So I store the information for... So I get the top from the starting block going up. Okay, I see. Then bottom is from the starting neighbor. Yeah, I have to go down. I have to go down. That's it. And here, yeah. Hopefully this is the only mistake. Okay, now it's much different. Now it's much different. And if I place some block, yeah, it's not perfect. Now let's make it like dark. Let's make it dark. So where actually? Where is the template? Template. Okay, let's just go to the iron block, generate here, here. Now for the colors, I just multiply the color, but I should add how should I do it? Let's see for the iron block what default colors do I set. I set the colors like this. I set the colors like this, and I want to make them darker, but it actually, okay, it's like, let's say it's 0.8 everywhere. The top and bottom are ones. How can I make color a bit darker? How can I make it darker? How can I make a color darker? How to darken RGB color? Color A, color B. So towards the dark, the black color, and he interpolates it. Which makes it closer to darkness. And how do they do it here? So here is the no, it should completely ignore it. Shader, darken color. Multiplied by color with the color vertex attribute. So let's say, let's simplify it. Let's simplify it here, and let's just let's multiply it by new vector for f, 0.2f, 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 1f. Let's do it like that, and to see have we darkened the colors. If so, this will make it easier. Yeah, we've darkened it. Yes, so here ambient values, ambient value, like this. What's the issue? Oh, I see, I see. I'm using, yeah, I saw my mistake. I saw my mistake. My bad. It's 0.7, 0.8, 0.9. I saw my mistake. Is it working? Let's make them stronger. So 0.2, 5, 3. Let's make them stronger. Yo! What? Yo! Not bad. But I need the foliage doesn't need to have ambient occlusion. Not bad. This one has just one corner and it's too strong, and it should be like split like this. So it should be, but here the wireframe is probably like this triangle and this triangle. And so that's why it looks like that. Okay, we can just focus on making the foliage not have ambient occlusion. So if it's foliage, so subchunk, ambient here, if the block has faces that are showing and block is not transparent, if it's not transparent. And now the foliage doesn't have ambient occlusion, but the blocks have it. Yeah. We have. It's not perfect because look at how this is split like this diagonally. But here it reaches to this vertex. I think because here, like a quad is made with triangles, two triangles. And I suppose this is one triangle and this is the other. and we set this vertex to be darker color, which stops properly to here. But here we set this vertex darker color, and the issue is that the triangle is split like this. So here it's darker and it spreads towards here and towards here. So can we do like this, this? Man, look at how much darkness there is. Maybe it's too dark. Maybe it's too dark. Yeah, but this thing, I think they mentioned it in the guide. Here, yeah, look at how here it stretches further away and here it's proper. Like this. It should be like this everywhere. Notice that the ambient occlusion is different for the vertices on the side and is for the vertices on the top and bottom. Yeah, the sides are different than the top and bottom. To fix this, we just need to pick a consistent orientation for the quads. This can be done by comparing the ambient occlusion in terms for each quad and selecting an appropriate orientation, supposing that are the ambient occlusion values for the 4 vertices of a quad stored in clockwise order, then we can correct this problem using the following rule. So we need to flip the quad. So for each vertex, we need to store, for each vertex, we need to actually store the ambient occlusion data. And if it's something, if we have this formula, we should flip the quad. And where should this happen? I'm not storing the values, so I probably need to store them. Sure, that's not a big issue. But where was it? Let's go to iron block. Iron block. And generate. Generate. And here I add the vertices for each face here. And then I pick their order. Where? Outside of here. Outside of here. So the only way I can flip the quad is when I create the vertices here. So I could calculate the ambient value here, and depending on the ambient values, to flip the quad when I add the positions, and then to store those ambient values so that I can add them in the coloring. So here, this calculation to not be done here, to be done here. Okay, without flipping them, I'll just do the calculation here without flipping them. That's the, let's commit it. Git add, git commit m first working ambient occlusion, git push. Let's just save it. Now I want this calculation. Here to calculate it, and I'll need like this, and here the start will be multiplied by 3 since that's how many like neighbors I need for each of the 4 vertices. And here I need to give the data. Need to give the data. And I will not need this. I will not need it. And I will need the ambient occlusion values only here in this class. Only in this class. And it's for each of the faces. I can have them as arrays, private, integer, south ambient data, and by default for each vertex it's the value 3. Let's just say that is the default. And I'll be right back. We're close to finishing it. I'm back. Oh, I had to go somewhere. Oh my god, I'm so tired. Yeah, I'm back. We cannot do it like this, like separate arrays, because the function is abstracted away. It doesn't know what south means. I need to change it. And it depends on, like, we can use this. And I can use it from here. Yeah, this. But they're too far apart. If I use some kind of a data structure, they're too far apart, the numbers, because if it's an 2D array, this will be like even the first they're too far apart, because I'll need to do an array of arrays that has 32 arrays, but I need only 6, I think. I need to store the data. Let me think about it. So, no, I don't need to do that. I don't need to do that. Yeah. I don't need to do that. I don't need to store the data. I don't need to do that. Now, we are trying to solve this issue. Here, look at how it's like that. It needs to be like this. So here, ambient value, we have 4 ambient values. So integer ambient values equals, let's make them just the integer 3, and then ambient values I, and then here if sorted in clockwise order, which one is 0, 0, 0, 1, 1, 3, 4. If so, this is ambient values 0, 1, 1 is 3, this is 1, and this is 2. else? Now we need to generate a flipped quad. We need to generate a flipped quad. And how do we do that? How do we flip it? This is the default. How? And I think, do we? Well, the only thing we're it shouldn't be here, actually. If I think about it, it shouldn't be here. Because if we flip the positions, the order is the same. I think. Or like, I think we have to flip all the data, not just the positions. We are flipping the quad. Because here, where do we generate it? Yeah, we generate it here. And I was thinking to flip the positions. I was thinking of flipping the positions, but we add the textures as well. We need to have the textures rotated. We just need to pick a consistent orientation for the quads. This can be done by comparing the ambient occlusion terms for each quad and selecting an appropriate orientation. Supposing that values for the 4 vertices of a quad sorted in clockwise order. Then we can correct this problem using the following rule. How can I do this as well? Because I have this problem. Because, like, look at what the issue is. I already have Xcal in raw. Now, we draw a quad by splitting it into triangles. And these are each of the 4 vertices. We set, let's say, this vertex to be darker. And the shader distributes this vertex color to all the pixels. And it works within the triangle. So it will spread it out like this, and it will not reach here. This is what we want. The issue is when the issue comes when the quad is like this. Then if we color this vertex, it will spread, and it will spread here, and that's how we get this situation. And it should be like this. So we should rotate it. And I was thinking to rotate the positions, but the textures will stay the same. The order, let me look at the ordering. Like we saw that we always start here, like when drawing a quad. We always start, like this is vertex 0, vertex 1, vertex 2, vertex 3. And then and then what is the ordering? It's in I do the ordering outside. For each quad I do the same ordering, which is 0, 1, 2, 0, 2, 3, 0, 1, 2, and then 0, 2, 3. That's how I do it everywhere. And I was thinking of if I want to rotate it, to change the order of the positions. So if I want the line to be like this instead. Here, I'm not sure how to flip the quad. Actually, like I could give the first vertex to be this. Then it will be if I give this as the first vertex, 0, 1, 2, 0, 2, 3. It will be like this. And if so I would have given V1 first. Like it's an array, actually. It's just an array. Here I give it V0, V1, V2, V3. I have to flip the quad. That's what I need to do. And here I give it V1, V2, V3, V0. Sure. This is if I just flip the vertices. The problem is I also give it the textures which I am not flipping, since I'm flipping the quad. And it will first, and it will be working, and here I'm giving it like, let's say, the texture. Oh, come on, man. Texture 1, texture 2, texture 3. And I'm giving the same thing here. I'm giving the same thing. So here it will combine vertex 0 with texture 0. So here will be texture 0. But here it will be texture 0. Here will be texture 0, texture 1, texture 2, texture 3. Let me think about it. This is vertex 0. This is how it should be. Instead of playing around with these arrays, it should be do vertex 1, vertex 2, vertex 3, then vertex 1, vertex 3, vertex 0. That's it. And I do it here. This is what I need to change. So indices, yeah, I'll need to get the indices the same way I get all the other things. Yes, I think. So get textures. So I need get indices which is of integer. Yeah, which is of integer. And here it should be just where in the I'm lost. Sub chunk and here I need array list. Oh yeah, and where is get positions? Here. This to be this. New integer. Indices. And here indices integer. And here I need to clear them. Here I need to add all templates I indices. That's it. And here I need positions. Here I need indices, integer. Here I need to indices clear. And that's it. And let me think about it. Let's make a function conditionally at indices, and here we remove all of this. We remove all of this. We don't need this. Like this, conditionally at indices. And here we don't need this. Here, what's your issue? We don't need this. Next, we need to actually add the indices. We don't need this. And so subchunk indices integer in indices array list here indices get indices like that, and here we remove this and this, and here indices to array integer int yeah, this is a bit of an issue. I have an array list. The indices is an array list of integers, but that's the class integers. And here indices needs to be of type ints. Yeah, it needs to be type int. Java integer array to int. Yes, this is what I need. Using streams. Okay, stream map to int to array. That's it. That's it. Okay. And let's just focus on having the same result as before. We need to change the colors. But how? Where did we change the colors? Here. Yeah, but it was given the right color. This is a bit of an issue. Here's the issue. I need the ambient data of each vertex, both when creating the indices and when creating the colors. And can this be int? Yes, it can. Okay, we have the ambient values. We have the ambient values. And let's also have color. Color, it has start as well. Let's have here a color. And so we need to give it south color, north color, west color, east color, top color, bottom color. That will be the solution. And we need to multiply the color. And so color multiply by this value. And here we don't need this anymore, I think. And here we need to create the indices. And this is the issue. Oh man. This offset. Because I need because when creating the quad, or it can be, I was thinking of an offset. I was thinking of an offset. I cannot create the indices through here. I cannot do that. It has to be through here because of this offset. Like sure, the ordering of vertex 0, vertex 1, like the indices is like which vertex are we working with, and the vertex ID is an integer. The first 4 vertices are from 0 to 3. The next ones are from 4 to 7, I think. And where the current face is starting from, we don't know. We don't know from where the current face is starting from, because we need to put like indices at, and here like we need something. Or the other idea is to just have an array of Boolean values for each face, whether it to be flipped or not. And to go through the Boolean values here. And when I push these, to also have access to a Boolean value for the face, if it should be like flipped or not. That's it. That's what I can think of as a solution. And that's what we will do. Or will that be just used for the ambient occlusion? Because the only thing it does is if we are flipping the quad or not. But if we decide to make some rotations later on, can we make it more general use case? Like to not be... Look at how I can have I can do it another way. Indices once more. And to... Yeah, it can be indices. And look at how every time we start from offset. It can be like this. And here we'll just remove these ones, but we'll add the offset. That's what we can do. Yeah, but let's copy it. And let's remove this. And here it will be plus equals. And that's it. And here it should be let's do it here. Indices at, so 0. 0, 1, 2, then 0, 2, 3. This is the ordering, and we'll flip them, but we need to check if everything is working like before. Everything should be like before. Not quite. Yeah, the colors are bad. We need to make it like it was before, and then we can do the part where we flip them. So how do we do it? Here, when I calculate them, oh, I see. Yeah, I cannot do it like that. Because the color that I have is for the whole quad. The color is for the whole quad. Yeah, okay, let's do... Yeah, let's do... Yeah, I'll change it. So we will have... yeah, private int north ambient data like this. South, east, west, top, bottom, and ambient data, ambient data. Instead of a color, we'll give it the ambient data. Here we'll get int ambient data, and here we'll do this, and when we add the colors, here we need also the ambient data of each vertex. And so south ambient data, north ambient data, west ambient data, east, top, bottom, and then here we go over all the faces. We go over the 4 vertices. Here we add the same color, but it should be a vector 4f color. It should be this color. Current color, and it should be multiplied by the ambient values, and then we add that color, and then that should be it. Now it should be like before. Yeah, now it's like before. And here we have that issue. Now let's see if we will solve this issue, if we can flip the quad. Now let's say here, when do we flip it? And generate flipped quad. This is the normal, and here it should be the flipped. This should be the flipped quad. So the flip, let's say it's from 1 to 3, and then from 1 3 0, and let's see if this flips the quad. Probably not. Not quite. Maybe I'm not actually flipping it. Let's go back. And am I putting them in the right order? Am I putting them in the right order? Because he says, are the ambient occlusion values for the 4 vertices sorted in clockwise order? And they are in counterclockwise. They are in counterclockwise, so they should be 0 is 3, 3 is 0, 2, 1. Maybe like that. Now they are in clockwise order. Not sure. Here it's reaching farther than it should be. And how should I do it? Flipped quad, normal quad. How to flip a quad? That's my question. Because I'm just rotating it. I'm not flipping it. And let me flipping it. So if I'm here, yeah, flipping it. So, so it should be like, it should be, let's remove this. It should be if we flip it, it should be like this, I think. So V1, V2, V3, V1, V3, V0. Yeah, I think I'm doing it right. So probably the conditional is I'm doing wrong. I'm getting them from here, which they are always from the bottom left. So here, bottom, yeah, bottom left, bottom right, up right, and up left. That's how I have them. That's my ordering. In counterclockwise. And clockwise will be let me bring it back as before, and let's comment this out. We're almost done, man. We're almost done. So the default is like this. And so here is where the quad is split. Here the quad is split like this. It needs to be like this. Here the value is 3, 3, 3. And here the value is, it has only one corner. It has only one corner. Value is 2. Value is 2. So it's 3 plus 2. And by default, this is like my normalcy. And for that quad, it's 3 plus 2. Yeah, how should it be? It's the top quad. We're looking at the top quad. And the top quad, where is north? Here is the sun. It's rising from here. It's rising. So east. This is probably east. This is probably west. And here it's this corner. But if it's like this corner, it's all right. If it's like, yeah, if it's coming from this corner or if it's coming from this corner, they're bad. If it's coming from this corner, it's good, and from this corner, it's good. Only when it's here or here, we need to flip it. Yes. Yes, yes. And so here, yeah, when the coloring ambient occlusion is here, it's fine. When it's here, it's fine. And when it's here, it's bad. Yes. And yeah, I think we can do it. We can figure it out. Here, let's uncomment this. Actually, let's no, let's leave it. Now we need to see. I don't need this. We need here if so here it's like the default is 3 and when it's darker it's less of a number. So let's say here it's 2 and here it's 3. And when do we flip it? Like he adds them together and compares them, which one is bigger. So if I combine these ones, it's 5. But if it's like the other case is here 2 and then 3, 3, 3. Here it's fine. Yeah, I should combine V0 and V3. And what's the other case? And the other case is 2 3, 3, 3. Yeah, I can look at the diagonal. If this diagonal is less than this diagonal, I flip it. Yeah, so V0 and V2. So if V0 and V2, and here V1 and V3, and I flip it. Yeah, that solved it. Now it's perfect. And it looks to be all right in the other cases. I think we finally have ambient occlusion. We can lower it to be not so obvious. Yeah, but I think we finally have ambient occlusion. Yeah, we have. Look at it. This is exactly ambient occlusion. Perfect, man. We have ambient occlusion. We have ambient occlusion. Look at it. What? We have ambient occlusion. Dude. Yo, look at how dark it is here. It's perfect. But it was so much work. It was such a big struggle. Let's make it look prettier. I need to change the ambient occlusion values. Ambient. Where's the array? Here. So let's do 3, 4, and 6. Is this better? Probably. Or maybe I can do 5 here. Now off. Now is it better? Yeah. And how does it look? How does it look? Yeah, it's... let me remove all of these items. Yeah, we have ambient occlusion, and I improved the movement. This is perfect, man. In 2 streams, we managed to improve we managed to add smooth lighting, and we managed to add Half-Life like movement. Yeah, look at it. You have ambient occlusion, man. So cool. How is it with piston? Yeah, even with the piston, we have ambient occlusion. What if we move it? Okay, like this, we don't have ambient occlusion. I don't know why. Oh, because I've made it transparent. Yeah, I'll think about it. But we managed to do most of the hard work. Yeah, look at how here at the edge, it's darker. It's darker. Here around the block is darker. And here is a lot darker. If I add a block here, same. Yeah. Yeah, look at how it added darkness here. Darkness here. Now darkness here. It's a lot cooler. What if we start mining? Ignore the item drops that are flying upward. I know what the problem is with the items flying upward. Yeah. It's because I made the gravity positive. And it was negative before. Yeah, this is how it looks like now. For 5 hours, we managed to add ambient occlusion. And yeah. And that's it. Man, this is so cool. We improved the project a lot. Yeah, look at it from the distance. Yeah, this is cool. Yeah, thank you for watching.